we've got up on the board the four functions that we're using to describe the position and the behavior of our particle that is moving with respect to time. I'm going to just remind you we're measuring time in seconds and position in meters. Okay, and the first thing I want to take a look at is the difference between displacement and distance. Displacement is just the change in position. And it would have to be the displacement over a particular time interval, and so we'll be using the time interval from 0 to 4. I can calculate a change as just a subtraction problem. So this is just the ending position minus the starting position. Okay, so if I were to calculate the displacement over the time interval from 0 to 4, it would just be the position at time 4 minus the position at time 0. So let's go ahead and calculate that. At time 4, if I plug in 4, I get 4 minus 2 squared. And when I plug in 0, I get 0 minus 2 squared. That's 2 squared is 4. That's negative 2 squared, which is 4. We get 4 minus 4, which is 0. So the displacement in this case is 0. The position overall did not change. Now, clearly that does not mean that the particle wasn't moving, okay? Because this was not a constant function. The velocity was not constant at 0. The particle was moving. With the displacement is 0, that doesn't mean that the particle didn't move. That just means that the particle returned to where it started. So right now I'm standing here, right in front of this dot on the board. Okay, I can move over here, I can turn around, I can come back. My displacement is 0. My starting and ending position are the same, but I did actually travel. Okay, so the distance would measure how far I actually walked on that trip. Displacement just measures the signed distance between my starting and ending point. Now you'll notice I didn't say the distance between my starting and ending point. I said the signed distance between my starting and ending point. In this case, we got 0. Okay. But since it's ending position minus starting position, it's just a subtraction problem. If my ending position is to the left of my starting position, for this problem we're using left as the negative direction and right as the positive direction, then I would get a negative number for this. Okay, so displacement is a signed quantity. Okay, distance on the other hand is never going to be negative. If I go out for a bike ride, I never bike negative 10 miles. I can bike 10 miles in this direction, I can bike 10 miles in that direction. Usually I would bike 10 miles in a loop so that my displacement is 0, so that my starting point and my ending point are the same and I can put my bike back in the garage. Okay, so that's displacement. How do we calculate distance then? Well, let's think about it. With the trip that I just acted out, I walked over here, then I turned around, and I came back to here. If we wanted to measure my distance, I would have to break that trip up into 2 parts. I walked over here. When I get to the point where I turn around, let's stop and measure that distance that I walked, and then I'm going to walk that same distance back. So I would have to break the trip up into time intervals over which I was going in the positive direction and over which I was going in the negative direction. To know what direction I'm going in, I'm going to need to know the sign of the velocity. So let's do that for this particular position function. I know that the velocity is 2t minus 4. I'm going to just make a note that that is always defined. I write AD as my abbreviation for always defined. If something is always defined, then the only way it can change sign is when it's 0. In general, something could jump from positive to negative or negative to positive, but if it did that, it would have to do so at a place where it was undefined. Because if the derivative jumps, it's at a place where the derivative isn't defined. Okay? So, if it's always defined, the only way it can change sign is by passing through 0. So I'm going to set this equal to 0. And when I do that, I get 2t equals 4, t equals 2. Now that's in the time interval that I care about. So I can say, here's my time axis from 0 to 4, and I'm just going to record the sign of the velocity on this number line. It might change at 2. The fact that it's 0 at 2 doesn't guarantee that it changes sign there, but it could, so I'm going to check. That's the only place that this could possibly change sign, because it's always defined and it's only 0 at time 2. So what that tells me is that over the time interval from 0 to 2, over that first 2 seconds, the velocity has a consistent sign. So what I'm going to do to try to figure out what that sign is I'm just going to plug in a test number. 1 is in this interval, so let's plug in 1 to the velocity function. If I plug in 1, 2 times 1 is 2, minus 4 is negative. So over the first 2 seconds, the velocity is negative. From time 2 to 4, over that second 2 seconds, let's plug in 3 to the velocity to see what the sign is there. 2 times 3 is 6, minus 4 is positive. It's 2, but it's positive. That's what I care about, okay? So what this tells me is that over the first 2 seconds, the particle was actually moving to the left, and then over the second 2 seconds, it was moving to the right. So when I enacted a situation where my displacement was 0, I went to the right and then to the left. What this particle did is the opposite of that. It went to the left, and then it turned around and went to the right and returned back. So what that tells me is that if I want to calculate the distance, I'm going to have to break this up into these 2 time intervals. Okay. I can say that the distance is going to be the sum of 2 absolute values. I'm going to calculate the absolute value of the displacement over the first 2 seconds. So that would be p of 2 minus p of 0. And then I'm going to calculate the absolute value of the displacement over the second time interval. That would be p of 4 minus p of 2. Okay. So I am not saying here that distance is the absolute value of displacement. That would be a lie, because we just calculated that the displacement was 0. Okay? But if a particle doesn't change direction over a time interval, then over that time interval, the distance will be the absolute value of the displacement. So that the total distance will be the sum of the absolute value of the displacement over time intervals where the velocity was a consistent sign. I will write that down in a moment. Let's actually finish calculating this. Okay. But the idea basically is the particle started here. Over the first 2 seconds, it was moving to the left. Okay. So we calculate how far it moved to the left. If I calculate the displacement over that time interval, it's going to be negative. Let's see that. P of 2 is actually just 0, because that would be 2 minus 2 is 0 squared. P of 0, we said, was 4. So the displacement here was negative 4. That indicates that we ended up 4 meters to the left of the starting point. But the distance that we traveled then is the absolute value of that negative 4. We traveled 4 meters. The negative just tells us that it was to the left. Okay. And then over this second time interval, P P of 4 we said was 4. P of 2 we just calculated was 0. So we get 4 plus 4 is equal to 8 meters. Okay. You'll notice it makes sense that our displacement was 0 because we went 4 meters to the left and then 4 meters to the right. So the distance that I went to the left and the distance that I went to the right were the same. When I'm calculating distance, I add those together. When I'm calculating displacement, I take into account the direction. Negative 4 plus 4 would give me 0 for the displacement. Okay, so let's just write out our description of the distance. Okay, so for distance, I'm actually going to, instead of just writing a definition of it, I'm going to write out the process by which we find it. Okay, first of all, break the time interval into subintervals where the velocity does not change sign. So for this example, we had two intervals, one where the velocity was negative, one where it was positive. We couldn't just use the time interval from 0 to 4 because the sign of the velocity changed, the direction in which the particle was moving changed. Okay, and then we just add the absolute value of the displacement over those time intervals.